Hello, this is the video for let's doing our lesson on 3A, expanding and collecting like terms. So we'll get straight into it. Once again, it's a little bit like revision, but it is skills that we need, fundamental algebraic skills that we need to make sure that we get really good at. So there's quite a lot of examples, so we're going to get started straight away. Here we have 2x minus 5 minus 3x plus 5. And some things to note, obviously, is that this 2 is going to multiply with the x and with the 5. And this negative 3 is multiplying by the x and the 5 here. Just some basics that we need to make sure we cover. The reason I said negative 3 was because I'm looking at this, and this becomes negative 3. So we're going to be very careful with that here. Okay, so when we do the next step, it's 2x minus 10, because it's 2 times negative 5 here, so it's 10, minus 3 times x, which is 3x, minus, so remember this is negative 3 times 5, which is negative 15, so here we have negative 15. So we've got to make sure that we understand that this is negative, okay? Got to be very careful with that. Then we combine like terms, 2x, so we'll use different color, 2x minus 3x, and of course we have negative 10 minus 15. So we combine the like terms, 2x minus 3x is negative x, negative 10 minus 15 is negative 25, and there is your answer, okay? So make sure you follow those rules correctly and you'll be fine. Okay, second question, 2x, 3x minus 2, plus 3x, x minus 2, like this. Okay, so once again, I'm not going to draw the red lines this time. You should know that we're going to expand. So it's 6x squared minus 4x plus 3x squared minus 6x. So once again, I'm going to use my highlighter to show you what we're looking at. 6x squared plus 3x squared. Notice that I'm including the sign at the front. So this is negative 4x minus 6x. So we're going to do the operations correctly here. Okay, 6x squared minus 3x squared, 9x squared. Okay, and then we have minus 4x minus 6x, which means negative 10x, like this. Okay, that's the answer. Moving forward. Okay, now I'll do the first one I'm going to do with the red line so you can see how this works if you forgot how this works. So we have x times 2x and then x times negative 3. So this is times, but then we also have to do 3 times negative 2x. So 3 times 2x and 3 times negative 3. So it's like this. So what's going to happen here is x times 2x is 2x squared. X times negative 3, negative 3x. Positive 3 times 2x, 6x plus 6x. And of course, positive 3 times negative 3, negative 9. And we just combine the like terms, which is this, equals 2x squared minus 3x plus 6x is just 3x minus 9. And there's your answer. Okay, it's pretty straightforward. That's A. Then we'll do B. Okay, so here we have x minus 3, 2x minus 2 root 2. Okay, so x times 2x is equal to 2x squared, obviously. X times negative 2 is root 2. We're going to write negative 2 root 2, put the x here. Okay, then finally you have negative 3 times 2x, which is negative 6x, and then finally, this is the finally, negative 3 times negative 2 root 2 will be positive 6 root 2. Okay, we're not finished. We want it to be in this form. So this is the form that you've seen before, perhaps. It's a squared plus bx plus c. So notice that, oh, sorry, not a squared. That's not right. Ax squared. So a and b and c are all constants, okay, or coefficients in front of the x, and of course c is a constant. Then we have the x squared. So we want it to look like that. Right now, the problem is you can see these are like terms. But to be fair, it's very hard to add 2 root 2 with 6. So, like, there's nothing you can really do here. So what we're going to do here is still going to write the 2x squared. That's fine. But here, we're going to do this. So you have two options. I'm going to make a plus. Oh, actually, I'm going to make a minus, I think. Yeah, make it minus. So negative, and I'm going to put brackets here. So this is going to be 2 root 2, okay, plus 6. Okay, because it's encapsulated with the negative, so just so you're aware, because it's got the negative, it will be negative 2 root 2 minus 6 if we were to expand this, but we're just sort of factorizing it. Put the x, and then of course we write the constant at the back like this, okay? So the only difference between this question right here and this question is that the x coefficient, which is right here, okay, is the same thing as this, except there's no clean way of adding 2 root 2 with 6, so we just leave it like this instead of writing it as one single number. Okay, next one. Once again, this expansion is just going to be a little bit bigger. That's it. Nothing's really different in this question. So it's 2x minus 1, 3x squared plus 2x plus 4. So expansion is a little bigger, as in like this, and then this. That's it. That's the only thing that's really different, okay? So we'll just do it. Do the entire thing. So it's 6x cubed plus 4x plus 8x minus 3x squared minus 2x minus 4. Okay, then we just combine all the like terms. So I'll just highlight them for you so you can see. We need to make sure that we're very good at combining like terms so we don't mess this up. This is what combining like terms will look like. Okay, I think I'm missing an x squared, aren't I? I am. What have I done? I have missed a squared here. So it's 6x cubed. Oh yeah, so this should be squared. Then we combine the like terms, so positive 4x squared minus 3x squared. And then I use highlighter, and it's positive 8x minus 2x. Okay, so these are my like terms. Everything else stays. Notice that the 6x cubed stays at the very front. Nothing changes there. Then I do positive 4x squared minus 3x squared, which is, of course, x squared, or 1x squared, but just x squared. And then plus 8x minus 2x is plus 6x minus 4. Done. That's the answer. Okay, keep going. This is what we call a perfect square expansion that's going to be done here. Perfect square expansion, it's got a fancy name and it's got a fancy way of looking at it, but really it's pretty straightforward if you think about it. So here we have 3x minus 2 squared. Now, we have to think about this because it's being squared. Because it's being squared, technically, I'll write it in a different color so you can see that. I'm just going to show you. Technically, what we're doing is if you square a number, you just multiply that number by itself. So in this case, we're just multiplying everything in that bracket by itself. That's essentially what we're doing. And if we expanded this, we would get this. Okay, so there's no real changes there. That's what's happening here. But it just means you can get there in one step instead. So if you follow this perfect square expansion, you don't need to do the expanding thing. All you have to do is go, well, it's definitely going to be 9x squared. 9 because you're squaring the 3 and the x, plus, right, in this case minus because it's negative 2, so it's going to be minus 2 times AB, which is 3x and 2. So it's 2 times, so that's going to be 12x. Yep, and then we're going to plus, because it's at the end, it's b squared, so negative 2 squared is just 4. Okay, and that should be the answer, I believe. Because you're doing the 3x on negative 2. So if you were to expand this, if you were to do this with this, and then this, and combine the like terms like we were doing it before, you would get the same answer as this. Okay, but we're just doing it quickly because we got the rule of perfect square expansion right here. Okay, I'm just going to get rid of this so you can see it. Okay. Move on. Now we have difference of two squares. So this is the rule for difference of two squares. It just means that when you see this pattern where you have a plus b, or a minus b, or shouldn't use that highlighter, a minus b and then a plus b. So notice that these are the same terms, but just with different signs. It means you can use this rule, and suddenly you have a squared minus b squared. So what we have to do is go 2x squared, which is so we'll write the question first so we can get this right. 2x minus 4, 2x plus 4. So we'll just do a difference of two squares, so 2x squared. So we can write it like this just so you can see what's happening. Minus 4 squared. That's it. Okay, the reason of that, I'm just following this rule. I'm not doing anything fancy here. Okay, now this just means that 2x squared is just 4x squared minus 16. Done. That's the answer. Okay. Now, if you don't believe it, what you can actually do is you can actually expand it the same way that we've been learning how to expand it, and you will actually get that. Okay. You can try it for yourself. I don't have enough time in this video to do that, but try it for yourself. You'll actually combine the like terms, and the like terms will be the x's, and you'll cancel itself out. And you only have is a squared. Okay. So we can do the same thing here. We get x minus 2 root 7. And then, of course, x plus root 2 root 7, which allows us to do difference of 2 squares. So it's just going to be x squared minus 2 root 7 squared, okay, which is equal to x squared minus, now 2 squared is 4, but root 7 squared is just 7 because the square obviously unsquares, well, square cancels out the square root. So what we actually have here is 2 squared times 7, okay, because 7 gets cancelled, and then of course this just turns into x squared minus 4 times 7, which is 28. Okay, all it is, done. Finally, last one, two ways of doing this question. Obviously, you can expand. It's going to be a pretty big expansion. It could be just 1, 2, 3. And of course, you got to do 1, 2, 3. And then finally, you have to do the C, 2, 3. So it's a lot of work. Now, you can do that work, get the marks on the exam, or you can see that this is also a difference of 2 square question if you are able to notice it. So what I want you to see is, I'm going to do this. I'm going to call this something in this. So let x equals 2a minus b. That's what I'm going to do. Okay, let x equal 2a minus b. So you can see that 2a minus b is here, 2a minus b is here. Okay, what's going to happen? Well, if I did do that, I'm going to rewrite the question. So instead of writing 2a minus b, I'm going to write x plus c, and then x minus c. Yeah, because instead of 2a minus b, I'm running x, and because I just said before that x is equal to 2a minus b, so I'm just replacing. Okay, now you can see it's difference of 2 squares, right? So I'm just using the same rule that I used here, difference of 2 squares, this thing right here. Okay, I'm just doing that. So that means right now I have x squared minus c squared. And of course, I know what x squared is because I defined it at the very beginning, which means I need to substitute it back in. So this means that it's 2, also I'll just write it down as with brackets, 2a minus b squared, like this, minus c squared. Of course, we can do this squared thing. So I'll just highlight it so you know what I'm talking about. We can do this because we've done that with the perfect square expansion, which is right here. Okay, so we'll just do the perfect square expansion. So it means it's going to be equals 2a squared. Then we're going to do plus 2ab, right? So 2 times 2a times negative b. So that's 2ab. And then plus b squared. Okay, so that's what this is. Plus, of course, then we had to write minus c squared because there's a minus c squared at the end. Okay, then we just figure this out. So 2a squared, well, 2a squared is just 4a squared, like this, because the 2a is in brackets, so everything is squared inside. Minus, because it's 2 times 2a times negative b, so it's going to be a negative. So it's minus 4ab plus b squared minus c squared. And there is your answer. Let's just verify, just for sanity's sake, that I'm right here. So let's look at this question. Let's go to the actual answers and see. 4a squared minus 4ab plus b squared minus c squared. Yes, good. Okay, so it's going to take a little bit of work, but if you've done algebra before, it should be pretty straightforward. But make sure you get really used to this. Okay, this sort of skill, these are the sort of skills you will just need, and you got to be really good at them. So keep practicing. Okay, get your reps up, and you'll do well. Okay, have a good day. See you guys.